Okay, this is example 1 on locus. The question says, find the equation of the locus of a point Pxy that moves so that it is always 3 units from the origin. Okay, now the best thing to do, and the first thing to do when trying to do questions on locus is to illustrate the question in a diagram, okay, in the xy plane, like I have here, and I'll just explain what I've drawn here. So it says find the equation of the locus of a point Pxy that moves so that it is always 3 units from the origin. The origin is there and it's the point 0, 0. It's good to note that down, okay, because we're going to use that. There's the point P, which is 3 units from the origin. And that point P is always going to be 3 units from the origin. So clearly it's going to produce a circle. Okay, if that point keeps moving 3 units away from the origin, it's going to follow the path of a circle. So you can simply write down that the equation of that circle is x squared plus y squared equals 3 squared, right? And that will become x squared plus y squared equals 9. Now, alternatively, to work it out, you can use the distance formula. Okay, so if we find the distance PO, all right, we'll call it distance subscript PO equals, okay, and we use our distance formula that we know, all right, prepare our parentheses, all right, and then we just carry it out. So x minus 0 all squared, and then y minus 0 all squared. Okay, so the distance PO, they've told us is 3 units, so we're going to write 3 here, equals, okay, and then just clean this up underneath. So we've got the square root of x minus 0 squared is x squared, plus y minus 0 squared is y squared. Let's square both sides so we can get rid of the square root sign. So square both sides. Right, if we square the 3, we get 9. And if we square this side, we just end up with what's underneath the third sign, x squared plus y squared. So, therefore, the locus of the point of Pxy, or the point Pxy, is a circle with equation x squared plus y squared equals 9. Okay, and that's that question. Now, if you're asked a question like, here's another one, I'll just flip the page. You're asked, find the equation of a locus of a point that moves so that it is always 2 units from the point 5 minus 2. So, first of all, you would draw your diagram, okay, so I'll just quickly draw the diagram showing those points. So you can see for yourself where P is going, or, you know, what the locus is going to, or the path is going to be. So it says find the equation of the locus of a point that moves so that it is always 2 units from the point 5 minus 2. So 5 minus 2, let's say 5's there, minus 2's there, so 5 minus 2 will be there, right? Let's call that 5 minus 2 because we're going to use that. And the point always moves so that it is 2 units from that point. So let's call the point Pxy again. So you can put it anywhere, all right, on your diagram, so long as you are showing that the distance between P and this point here, all right, is 2 units, as they say, all right. That's 2 units. All right, so you would follow the same process as you did with the distance formula up here. All right, so you would write the distance is equal to, okay, square root of. Right, so again, it's x minus 5 squared, all right, plus y minus 2, which is plus 2. Squared. Okay, the distance they tell you is 2, so let's write that down. And then we just square both sides. so that we get rid of that square root sign. If you square 2, you're going to get 4, and you just end up with what's underneath the square root sign here. All right, and as you can see, that's a circle with centre 5 minus 2 and a radius of 2. Okay, so the locus of, they wanted to know the equation of the locus, so I'm just going to start that again. The equation of the locus is exactly that. We'll just write it the right way around. X minus 5 all squared plus y plus 2 all squared equals 4. And that's that. And if they ask you what is it, well, you can say it's a circle with centre 5 minus 2 and radius 2. And that's example 1.